Hello, everyone. Good afternoon. So my name is Derek Ewell, and I'm a Principal Solutions Architect with Amazon Web Services, specializing in SAP workloads. I am presenting together with Ferry Mulyadi, Alliance Partner Solutions Architect for SAP, and Wong Wai Long, Specialist Solutions Architect for SAP. We're today in, of course, the modernization track. This is session MOD301, Improve Performance and Security of Enterprise Workloads on AWS. We're excited to share with you today the crucial security, availability, and performance solutions for users of business-critical applications on AWS. We'll make you aware of the best practices and AWS tools that you can use to achieve these goals. This will help you ensure that you have a positive operational experience on AWS after your initial application go live, and encourage you to explore ways to continuously innovate, optimize, and modernize these critical workloads. So after a brief introduction, we'll spend time talking about the services and solutions behind several key concepts that can help drive a positive end-user experience. This includes observability, performance matters, security, and zero trust. We'll also run a demo of a potential customer scenario involving our zero trust solution, AWS Verified Access. And finally, we'll wrap it up with a few words of closing with some suggested next steps if you'd like to know more. So let's move on to the introduction. If you ever join an enterprise workloads-oriented presentation, such as for SAP from AWS, the contents of this slide shouldn't be too surprising. As you may know, AWS offers a lot of advantages for software intended for business-critical solutions, including SAP, Oracle, and Microsoft. Cost efficiency, scalability, resiliency, and security can all be improved with the simple act of deploying your workload to AWS. And additional modernization can take you even further by automating typical maintenance tasks and manual business processes, thereby extracting more value from your data and much more. And now AWS provides business applications to further enhance your enterprise workloads, such as the actionable, machine learning-powered insights provided by AWS Supply Chain, which aids in mitigating overstock or stock-out risks, improving customer experiences, and lowering excess inventory costs. We hope you had the chance to join the earlier session in this same track here to learn more about how AWS Supply Chain can help your business. However, we do find these discussions around optimization and so forth tend to be missing out on one key factor. So what do you think that is? No, frankly, it's this person over here on your left, my right. Your end user. They may be your colleague, your subordinates, your manager, or someone much higher, or even your customers and partners. They're interested in getting their job done by using one of the various clients, also to your left in this diagram, by connecting to their enterprise workload, such as an SAP system, on your right in this diagram. While all this fantastic transformation we spoke of earlier is happening and driving significant value for your business, often this person here is most concerned about more mundane topics. How fast can they navigate through each screen in the enterprise applications that they're using to get their job done quickly? When they tell you it's slower than normal, does your team know what they mean, and can you diagnose the problem? Could their application go down due to malicious parties gaining access to it? So in the end, they just want to connect to their enterprise workload running on AWS. Having this person as efficient as possible in doing that should be a key goal of your deployment. As often, the relative health of your enterprise workload is often perceived through the lens of how accessible and how responsive it is. So let's walk through a few ways we can ensure this happens, then build an architecture where they're all working together to solve your connectivity needs. So let's start with observability. Poor user experiences are everywhere. It can come from a slow mobile application, or even an unresponsive website or broken links. For e-commerce sites and search engines, or even enterprise workloads, such as SAP S/4HANA and AWS Supply Chain, this can cause a significant loss in users and/or views, and also revenue. So imagine you have a procurement officer that would like to order laptops for new joiners. If your SAP system that you use for procurement becomes well known for poor user experiences, then multiple procurement officers may skip it in the interest of time. So orders will be constantly placed outside of your negotiated agreements, and your operating costs will increase dramatically. So I think Ferry, who will come up on stage now, has some good ways to monitor this. Ferry?
I surely do, Derek. Thank you so much. All right, there's a saying that you cannot fix something that you cannot observe, right? So observability is very critical for us to understand enterprise workload behavior, right? It provides us with a baseline, whether your workload is behaving good or bad. And then from then on, you can create action items to improve the situation further. Now let's look at the first service that I would like to touch here, CloudWatch RAM, CloudWatch Real User Monitoring. So this is a very good services for observability because it provides you with client-side telemetry. So what it means, it gives you real user experience. Whatever slowness they encounter, whatever error they encounter, is pretty useful for you to know that the truly experience is there for you. And from there, you can correlate with the resources that you have, right? If the slowness is due to your database server or app server or the network, you can actually do deep dive into that services through Service Lens and X-Ray. And on top of that, you can measure the user impact as well. You can know where the location of the user is, the mobile device that they have, and also the browser that they use to access your system. And lastly, because of the fact that you get all the error stack and traces that leads to the situation that the user encountered, you can debug it more easily. And that means reducing the time to resolve the situation. And lately, in February 2023, CloudWatch RAM is supporting custom metrics. So you can imagine that you can track certain business critical application, for example, like SAP, and then you can start measuring the performance of that application for your users. Now let's look at how it works. So first of all, you need to install the RAM web client part of your enterprise workload. You have to open the HTML header, you inject the code into it. It's just a simple HTML code and JavaScript, few line items there. And then when the users launch the web browser, it will then report it back all these events, the navigation events, the JavaScript, HTTP errors, and also the client-side telemetries, right? All of these can be accessible through the CloudWatch RAM dashboard, so you can see what's happening with the users, right? And you can also feed this into CloudWatch metrics, yeah? And you can raise an alarm from there. So you can imagine if you know that certain business processes or apps is really critical for your business, you may want to set up an alert for that. You don't want to wait for the users to call you up and say, hey, Ferry, it doesn't work for me. What's going on? My truck cannot leave the factory. Please help me. But rather, you know it from the tool itself. And this is how it looks like, right? So the dashboard will tell you where the user's location is, the number of pages being loaded, number of sessions encountered by the users, and also the performance over time, be it tolerable, frustrating, bad, etc. And what I like from this dashboard is the ability to aggregate the user journey. So what it means, you can actually understand what the users are clicking when they are using your SAP system, for example. And therefore, you can actually create a realistic integration test for your development developers to fix the problem. Yeah, so you're no longer guessing how they are using it. Let's look at the other observability services that I would like to share. It's called Internet Monitor, right? So this is a enterprise workload Internet Monitor tool. It's useful, for example, if you want to make SAP available over the internet. Let's say you have a sales force that is going around meeting the customers and they want to log sales orders or something like that, or a maintenance worker who needs to go around the plants, logging defects and solving maintenance orders. And all of these workers need to access your SAP system through mobile devices. Yeah? And what it means is you have to open this enterprise workload to the internet. As you know, internet doesn't have SLA, it's outside of your control, right? Performance is unpredictable. So when these users log a ticket with you, normally what you can do is just check the health of the SAP system at the back. And there's nothing you can do with the connectivity, right? But now, with this CloudWatch Internet Monitor, you can actually know what's going on with the connectivity with the end users. Now let's look at this, right? So CloudWatch Internet Monitor all the traffic coming in and out of your VPC. So what it means, you can actually now tell the user, hey, probably your connectivity through StarHub is very bad. So maybe you may want to switch to Singtel or something like that. So you no longer have to be reactive in this scenario, but you can be proactive, telling your customers alternative way to fix their connectivity problem. Now, let's look at security. We have now heard about bots, exploits, malware, ransomware, and so on. So how do we make sure that our enterprise workload is also secure from all of these malicious actors, right? So there is one service that I would like to start first, which is AWS Web Application Firewall. Web Application Firewall operates at layer 7 in the OSI model. It is meant to protect your business logic against common cybersecurity risks that is known as OWASP. And WAF can temporarily patch your vulnerability without having a major code changes. You can filter and block malicious requests and reduce the security threat overall. One thing to note, WAF is not meant to replace your security infrastructure. This means that your shared responsibility at AWS is still applicable, and you should think your security holistically. So how does WAF works? WAF consists of a few things. The first one is Web ACL, Web Access Control List. This is a container of all the rule statements that will tell WAF whether to drop certain requests, or to pass through certain requests, or to just alert you when the request coming in. You can also look at the sample request for your debugging. You can look at the full logging of the request through the Kinesis Firehose, and you can look at the metrics in terms of volume that is coming into your enterprise workload. And all of which WAF can be attached to your API gateway to protect your incoming API requests. It can also protect the CloudFront for the web-based protocol like SAP Fiori, SAP Portal, or AWS Supply Chain. You can also attach it to your ALB if you have a web-based application, or you can also use AppSync to be protected with WAF. And we help you to jumpstart the implementation of WAF with managed rules. So you don't start from 0 rules, but rather you can reuse the rules that we already created by the threat research team. These are the team that is working on AWS Shield Advanced team. It is introduced based on OAuth's top 10 web application security risks, and it's available for you at no extra charge. Another security services that I would like to share is IAM Identity Center. This is useful if you have multiple enterprise workloads within AWS, or if you have multiple accounts, and you want to aggregate, you want to consolidate your users, your groups, your permission into central location. It can protect your organization by delegating security administration to your subsidiary or department, and you can implement customized policies based on your security policy within the organization. IAM Identity Center is highly integrated with AWS services like AWS IoT Sitewise, AWS SageMaker, and so on. It is also pre-configured for SAP, AWS Supply Chain, Salesforce, Box, and Office 365. And lastly, but not least important, is it comes with a pre-configured wizard for SAML-based application. And recently, we also enhanced this for OpenID Connect. All right, so that's for security. Let's talk about performance. Over to you, Ilo.
Performance. Let's focus specifically on poor user experience. Now imagine that you are trying to access your favorite e-commerce website or stream your favorite TV series, only to find it loading very slowly. That would be a very frustrating experience. So what can we do to minimize these sort of situations? Let's talk about Amazon CloudFront. So Amazon CloudFront is a content delivery network service that is able to deliver content, digital content such as images, videos, web pages at low latency and high transfer speeds from edge locations. So when a user requests for content that is through CloudFront, for example, you access a website or via an application, that content is routed through to the closest edge location from where the user is. Now, if that content is cached by CloudFront, then that content is obviously delivered with minimal latency and optimal user experience to the particular user. CloudFront is also fully integrated with AWS services, such as the web application firewall that Ferry spoke about earlier, and also provides DDoS protection through our Shield service. But let's talk about how we can use CloudFront for enterprise applications like SAP. So in the case of SAP Fiori, which is SAP's web-based application, you can actually use CloudFront to cache static SAP Fiori content in order to improve the SAP user experience, thereby reducing the overall SAP user response time and making your users happy. But what if your application is not web-based? Then what do? Let's talk now about AWS Global Accelerator. AWS Global Accelerator improves the availability and performance of your applications by routing your user request to the closest edge location, and then from there, routing it through the global AWS network backbone, then directly to your application. So by doing so, it reduces overall latency and gives you the optimal network path and hence a better performance as well. So let's look at an example using SAP. So let's say in this case, we've got SAP users in Malaysia, Thailand, and Indonesia wanting to access the SAP system located in Germany. Using a feature of Global Accelerator called Accelerated Site-to-Site VPN in order to encrypt the SAP traffic, the user request is routed to the closest edge location and then routed through to the AWS global backbone directly to the SAP application. So we've basically talked about CloudFront and Global Accelerator, and you may be thinking, are these complementary services? Can you use them together? So absolutely. So CloudFront to cache SAP Fiori content because it's web-based, and you can obviously use Global Accelerator to accelerate SAP GUI type workloads. And SAP GUI is obviously SAP's thick client in order to access the SAP application. So you get the best of both worlds. All right, so now let's pivot to a security concept known as Zero Trust. SAP, as many of you may be aware, is a business-critical application. It's typically the heart and lungs of your company used to run your business. Because of the criticality of the application, SAP is typically located deep within the corporate network, behind layers of corporate firewalls, behind private subnets. But what if you have a requirement to expose the SAP system in a secure way on the public internet, quickly and easily? So let's talk about our newly launched Zero Trust service, AWS Verified Access. AWS Verified Access provides secure VPN-free access to enterprise applications such as SAP. It improves the overall security posture as there's real-time validation of the user requests, unlike traditional VPNs, whereby the user login is done once in the beginning, and that's it. Secondly, it improves the overall end-user experience as well, because there's no need to install VPN software in your user devices, which are typically cumbersome, which typically take up unnecessary resources, and obviously you have to have your IT teams to manage the VPN software as well. Thirdly, it simplifies operations because AWS Verified Access provides fine-grained, granular security policies that allows you to permit or deny access to users and/or devices. So let's say, for example, you have sales teams out and about outside of the company needing access. So you could permit just your sales team's access to the corporate application, like SAP, and also combine that with allowing only corporate devices access into the corporate applications as well. So let's see it in action and talk about the demo scenario. But before that, can I have a show of hands, please? Who here loves durians? I was expecting more hands up, but that's okay. That's okay. I think that's hopefully something that we can change, seeing that you are based in Singapore. So Unicorn Fruits is a durian distributor based in Singapore. It's recently undergone a digital transformation journey and migrated its SAP systems onto AWS. It has sales teams in Malaysia, Thailand, and Indonesia wanting secure access to the SAP S/4HANA system from the public internet. So let's just talk through the demo architecture. So on your left, you've got the sales teams wanting secure access to the SAP system located behind a private subnet in the AWS Singapore region. So firstly, we define a trust provider. A trust provider provides identity information around users and devices. And in the case of the demo, we've actually integrated it into AWS IAM Identity Center. Now, AVA also supports third-party trust providers, such as Azure AD or Okta, for example, and even device trust providers, such as CrowdStrike, who has a booth outside, and JAMF as examples. So via the trust provider, AVA then is able to either permit or deny access to the required users and/or devices. Next, we define the verified access instance. So the verified access instance is essentially the engine of AWS Verified Access. Within the verified access instance, we define the verified access group, which contains the security policies that again allows you to define who or what has access to the corporate application. So in this example, we want to allow only the sales team's access to the SAP system, but not anyone else outside of the corporate network. And perhaps also allow only corporate devices. So that means personal devices cannot access sensitive information stored in SAP. And finally, we define the public endpoint. So in the case of this demo, the public endpoint is secured.nicnat.top, which is then mapped to an internal load balancer in AWS, which finally points to the SAP system. Sounds simple, and I'll just show you how it works. So in the demo, I'll show you what success looks like. I'll show you the end result first, i.e. we've actually connected my user through AVA into the SAP system located in a private subnet in AWS. And then I'll talk about how we set up AVA to connect into SAP. Okay, so firstly, we've got an incognito browser window, or we've actually opened a private browser window. So just showing you how it works. So in this case, I key in my public endpoint, as you can see there, secured.nicknet.top, and the Fiori URL to access the SAP system. So it points me through to the AWS IAM Identity Center, which is my trust provider, where I key in my user ID and password. And then after that, via single sign-on, authenticates me to my SAP Fiori system. So as a sales guy based in Malaysia, I then get access to my sales roles in SAP. So let's quickly talk about how we can set this up using AVA. So firstly, within the AWS console, we have to go into the AWS IAM Identity Center in order to create my user ID. So in the case of the demo, this is obviously pre-created and pre-recorded as well. So my user ID has been created and validated through the IAM Identity Center. Next, we define the verified access instance. So the AWS Verified Access service is actually located within the VPC dashboard of the AWS console. So we create the Verified Access instance here, as you can see. You specify a name, a corresponding description. You specify the trust provider that we created in the previous step. Next, we create the Verified Access group. So again, specifying a name, a suitable description, specifying the earlier created verified access instance. And here again is where we specify the security policy. So in the case of this demo, I've actually permitted access to my email address through AVA, and also set up single sign-on, connecting IAM Identity Center to the SAP system. So once the verified access group is created, finally we create the public endpoint. Okay, so once again, repeating the previous steps in a similar fashion, specifying the name, the description, specifying the verified access group, the application domain, which in this case is my public endpoint name, secured.nicknet.top. We also specify the domain certificate because as a public endpoint, we store the SSL certificates in AWS Certificate Manager. And then specifying the VPC details, the security groups, the endpoint type, which is an internal load balancer pointing to the SAP system on the SSL port 443. And there's also an option to additionally specify additional security policy details pertaining just to the endpoint as well. So fine-grained, granular security policies are definitely possible. And yeah, so this is the end result. So the application domain, or the public endpoint, as you can see highlighted, pointing to the internal application load balancer, which in turn points to the SAP system. And that's it. So over to you, Derek.
Okay, so yeah, let's go ahead and pull everything together. Now, first of all, of course, thanks to Wai Long for sharing on AWS Verified Access. It's a great option to consider versus the less flexible traditional approach of established VPNs. So we've spoken about different ways to enhance the performance and security of users connecting into enterprise workloads like SAP. And each of them has their own values to address the end user's connectivity needs. But let's go ahead and build an architecture where they're all working together to solve these needs. We'll start with a trusted network-only solution, which supports any network protocol, such as that used by the SAP client SAP GUI, via AWS Accelerated Site-to-Site VPN. It uses AWS Global Accelerator for optimized network connectivity. And as it is a site-to-site VPN, the connection is generally between AWS to the various corporate offices. As you can see there, there's also an element of transit gateway, which helps being the so-called landing point for your inbound network connection. There are even more advantages versus traditional VPNs if the user and the SAP backend are geographically separated. And this is because AWS Global Exciter is there to provide that optimized remote network connectivity, where the last mile, or at least last many miles, will go over AWS optimized networks from the closest endpoint in that particular area to where the user is working, all the way over to the AWS region that the workload is sitting in. Now, for web-based clients, AWS Verified Access can support traffic without the overhead of a VPN, while still ensuring only properly configured and authenticated clients are able to communicate with the backend by using the concept of zero trust. As this is over the internet, encrypted protocols are recommended for your client, such as using HTTPS together with SAP Fiori. And of course, as you heard earlier, IAM Identity Center would be added for use with AWS Verified Access to ensure that users are properly authenticated to the backend application. Now, another option for these sorts of clients, ones that are using a web-based access mechanism, is Amazon CloudFront. This is the best choice for SAP Fiori or other web-based clients when the connections would need to travel long distances over the internet, because firstly, it provides the same sort of network optimization as AWS or Amazon Global Accelerator, but can also cache static content for faster downloads. Now, the last mile on this, you see there is an application load balancer. This application load balancer will communicate with the SAP Web Dispatcher and then into the SAP application, if that's the workload you're using. And although some level of distributed denial of service or DDoS protection is available with CloudFront by default, further securing your enterprise applications through AWS Web Application Firewall, or WAF, and AWS Managed Rules is a recommended addition. And finally, we should use Amazon CloudWatch to monitor the health of our workloads, including the health of our users' connectivity through Amazon CloudWatch Real User Monitoring and Amazon CloudWatch Internet Monitor. Now that we have the full architecture assembled, we can now see how all the different solutions we discussed actually work together. Now let's see how one of our customers in the region are using AWS services to secure and optimize their SAP on AWS workload. So for those of you from the Philippines, this name may look a little familiar. This is Aboitisland. They're a real estate developer in the Philippines, and they've implemented AWS security mechanisms for their SAP workload. While their initial goals were to reduce technical debt and reduce the in-person requirement for IT and SAP-related operations by using cloud-based services, they also realized that they can run more securely and in a more compliant fashion by running on AWS. Through observability features such as Amazon CloudWatch, data at rest security through storage-level encryption, and Amazon Guard Duty for intelligent threat detection, they can more confidently deliver high system uptime for their end users while protecting business-critical data. Now, as we start to wrap things up, I'd like to leave you with a little bit of a reminder. One quote I've always enjoyed, as it really makes you think, is by our CTO, Werner Vogels. Werner likes to say, everything fails all the time. Now, this is not really a negative thing per se. This is a reminder that regardless of how reliable you think something is, there's always a chance it may fail, and you should design to address that eventuality. There are resiliency features and architectures available for the services we discussed during this session, so we encourage you to consider them as you build out your own workloads on AWS. And don't forget about our training and certification offerings, including Skill Builder to help your teams build out more knowledge on AWS. And of course, before you leave, because I notice people are already thinking about break time, please consider, and after a quick thanks, of course, for all of you for attending, please make sure you complete the session survey. Okay, so the session surveys are valuable for us as speakers because it helps us know where we did well and also for where we should focus on improving in the next session. Anyways, that's it for now. Thanks everyone for your time this afternoon. And please enjoy the rest of the summit. Thank you.